this video, we're going to begin talking about lines and linear equations. Straight lines are frequently employed in business decision making. It's truly astounding how many applications there are for straight lines. Lines are used in business for forecasting and for data analysis. So forecasting is trying to predict the future so that you can plan. Data analysis is looking for trends and patterns in data in order to gain insight from what is present there. A statistical technique called linear regression analysis finds and quantifies the trends in data when the relationship between variables is linear. That means when the relationships are well approximated by a straight line. And again, I say, it's astounding how many relationships between variables in the real world are well approximated by a straight line. Maybe not perfectly, but well enough to get you to the next decision that you need to make. Linear regression is also used to predict what will happen next to a single variable that changes over time. For example, companies can set targets for this month's sales based on the sales in the last few months using straight line techniques. Linear regression will not only come up in your statistics classes, but also in your supply chain, marketing, management, and finance classes. It is ubiquitous. It's everywhere. Linear equations also form the basis of the important planning technique linear programming, which is abbreviated or shortened LP. LP models determine how to allocate resources within a company given constraints to maximize profit or minimize costs. These kinds of linear programming models are astounding what they can do. For example, UPS solves LP models every day to allocate its trucks onto their routes in order to minimize its costs and maximize its profits. Sounds complicated, and it is. You'll use Excel Solver to solve LP models. But the thing is all of the formulas that those models are based on and all of the things that have to be set up in order to use them will be linear equations. So I hope I've convinced you that there is reason to refresh your memory about what you knew about lines and how to deal with them and how to use them. So I've been talking about lines and linear equations. What am I specifically referring to? An equation, as we learned in our earlier unit that talked about equations, is any mathematical expression that contains an equal sign, that has a left-hand side set equal to the right-hand side. Equations that we're dealing with are going to contain variables, placeholders in the expressions where values can be plugged in to solve those equations. So linear equations are a subset of equations in general. Linear equations are equations in which the variables are all to the power of 1. So recall that x to the first power, which is x to the power of 1, is just x. So when you see just x, there's an unwritten exponent on it, and that exponent is 1. When 1 appears in mathematical expressions like this, it tends to be unwritten, because if x to the first power is just x, why not just write just x? Let's take a look at a linear equation given here. Y equals 9w minus 14x plus z plus 12. That is a linear equation because its variables, w, x, y, and z, are all to the power of 1. So you see you can have multiple variables in a linear equation, but all of the variables just have to be to the power of 1. Nothing squared, nothing cubed, no square roots because square root is just to the half power. No cube roots because cube root is just to the 1/3 power. None of those powers can be in there if they're on variables. Any variable in a linear equation may be multiplied by a constant. The equation is still linear even if its variables are multiplied by constants. In this example we're looking at, the w variable is multiplied by 9. The x variable is multiplied by negative 14. Both the z and the y variables are multiplied by 1, which is not written out. When a constant is multiplied by a variable in an equation, the constant is called the coefficient on that variable. So when a coefficient is 1, it's usually left unwritten. The other thing linear equations can have is a constant term, which is not multiplied by any variable. 12 is the constant term in the example that we're looking at. If a linear equation does not have a constant, what does that mean? It means the constant is 0. The constant is 0, it's not written out because it doesn't make any difference. Our example shows the equation solved for y. What that means is that the y is isolated on one side of this equation, so that you can easily plug in values for the other variables and calculate out your quantity of interest, in this case, y. The thing is, linear equations can be solved for any of their variables. If you have any questions about how to do that, see example 7.1, where we solved a simple linear equation for x when it started out solved for y. The most familiar linear equation for most people is going to be the equation of a line. In slope-intercept form, the equation of a line is y equals mx plus b. I write it this way because in business applications, it's almost always written like this. Slope-intercept is the one that gets used a lot because a lot of times when you're actually dealing with real data, you have a dependent variable and an independent variable or set of independent variables in mind. So you have something you're trying to explain, why are your sales what they are? And you might be trying to explain that using the experience of your sales force. You could use linear regression to tease out the relationship there. The dependent variable would be sales. The independent variable would be the experience of the salespeople. So when you start thinking of data analysis like that, you have to think of how the variables are connected and which one is dependent on the others. Because when you start doing data analysis, that's how variables are characterized. With its variable isolated on the left-hand side, the slope-intercept form fits naturally with the idea that one variable, in this case the y, is dependent on the activity of other variables and factors, which are collected on the right-hand side. So, I digress. Let me get back to the basic equation of a line. There are two variables in this equation, x and y. The letter m stands for the slope of the line, which is a constant and is multiplied by the x variable. So whatever is multiplied by the x is the slope. The slope defines the steepness of the line. So the slope is going to be either a positive number, a negative number, or 0. If it's a positive number, the line slopes up from left to right. If it's a negative number, the line slopes down from left to right. If it's 0, then the x drops out of the equation and you get a horizontal line. Whatever number the slope is going to define how steeply the line either climbs or falls. Mathematically, literally, the slope gives the amount by which y increases or decreases for a change of 1 in the value of x. We're going to talk about that more as we go on. The letter b represents another constant called the y-intercept. It is the value of y when x is equal to 0. So it marks where the line crosses the y-axis. When a linear equation has either one or two variables, it can be graphed on a coordinate plane where it looks like a straight line. So taking a look at our one variable examples, x equals 2 is a linear equation. How do I know? Because it has a variable that's raised to the power of 1. It has a constant. Both of those are allowed in linear equations, and so it is 1. X equals 2 is actually a vertical line that crosses the x-axis at 2. Y equals negative 4 is a linear equation because its variable y is raised to the power of 1. It has a constant, negative 4, that y is set to. You see that there's no mx in here. There's no x term. That implies that the slope of this line is actually 0. That's where the x went. 0 times x is 0, and that's why it would drop out of this equation. Y equals negative 4 would be a horizontal line crossing the y-axis at negative 4. The 0 slope shows that as x increases, y does not change. Taking a look at the two variables equation, y equals 4 minus x, this is a line that crosses the y-axis at 0, 4, because the y-intercept is 4, even though it's written as 4 minus x instead of negative x plus 4. The 4 remains the intercept, and the slope is negative 1. That negative 1 for the slope makes this graph slope downward from left to right. In example 7.1, we calculated many coordinate points on the line y equals 2x minus 1. We used that equation to solve for y given many different values of x. Then we solved the equation for x and solved it again for different values of y. The slope of this line is 2, and the y-intercept is negative 1. Now, we did calculate out the actual point for the y-intercept in example 7.1. But note that we didn't have to do that. From the definition of the y-intercept, we know that the point 0, -1 is on this line without calculating, because b in our y equals mx plus b formula is -1. All of the points that we calculated in example 7.1 are given in table 5. Let's graph this line. So example 8.1, this is table 5, which is a data table of points that we calculated in example 7.1 using the equation y equals 2x minus 1. We have a coordinate plane, and I'm going to mark that this horizontal axis is the x-axis and the vertical axis is the y-axis. In order to graph a line, you only need 2 points. Just because we're practicing here, I am going to do some more. Let's take the first point, x equals -1 when y equals -3. So x equals -1 is one step to the left from 0 on the x-axis. From there, we go down the y-axis 3 steps to -3, and the point goes where those two meets. Now let's do the y-intercept. Let's do this point, 0, -1. 0 on the x-axis is where the y-axis crosses. So we're going to be right on the y-axis. -1 on the y-axis is one step down from 0, so I'm going to put the pink point there. Okay, let's do one more point. I'm going to choose to do this one, 0.5 and 0, because it's nice and easy. When y equals 0, that is going to be right on the x-axis, because the y-axis crosses the x-axis at 0. X equals positive 0.5, so that's going to be halfway between 0 and 1 on the x-axis. So that blue point is actually called the x-intercept. Now we have 3 points, and if you have a straight edge at home, it's going to help you out a lot. Draw your straight line through them. Now in your math classes, you've probably learned that this line goes off in either direction to positive infinity and negative infinity and all of that stuff. In business, you're mostly going to be dealing with line segments because only certain ranges of numbers are going to be relevant to whatever you're doing. So some of that sort of falls by the wayside, but graphing points and using lines is never going to go away. Are we always going to graph lines by hand? The answer to that question is certainly not. Usually you will be using Excel or other software to create graphs. And we can do so in this case. In a way, it's not the best fit because Excel is not the same thing as a graphing calculator. Instead of taking an equation and making a graph from it, Excel makes graphs from the data itself. So we would start by entering the data in table 5 that we used for example 8.1 into columns in a spreadsheet. Then we could insert what Excel calls a scatter plot, because it's a scattering of coordinate points, with straight lines and markers. That's actually a thing in Excel, and it's going to look like what you see in figure 11. We are going to be able to make this fairly quickly. Here I am in Excel. The x variable is on the left and the y variable is on the right, and that is how you tell Excel that you want x to be on the horizontal axis and y to be on the vertical axis. Just orient the columns that way and you won't have to change anything afterwards. When you want to make a chart out of data, you have to highlight that data. The way you do that is you click your mouse and drag the highlight over the area that the data occupies. So these 8 rows in columns A and B, and then release the mouse button. That leaves it highlighted. Now I'm going to go to the Insert tab, Charts Group, and this button is the Insert Scatter XY or Bubble Chart button. I'm going to click the down arrow, and I'm going to choose Scatter with Straight Lines and Markers. As you can see, it has already made my graph. The only thing I changed before I pasted this graph into Word was to take the automatic titles away. There's lots of things you can add to this graph in Excel, but it's that easy to make a graph of a line. You don't need all of these points, these 7 points. All you would need is 2 points. As long as you had 2 points, Excel would be able to put the line on the graph. But it's going to use the most extreme points as the ends of the line segment it's showing you.